Welcome to this video about the fourth lab of microprocessor architecture about the RISC-16. In this lab, we will see the pipeline architecture for the RISC-16. I invite you to download the handout. Once you have opened the handout, you will see that we are talking about understanding the behavior of a simple pipeline processor, especially with pipeline hazard, and test some code with the RISC and compare with the version of lab 1. You will have another version of the simulator. I invite you to download it immediately. The RISC-16 pipeline simulator. In this lab, you will see the modified version of the RISC-16 architecture with a 5-stage pipeline. The instruction can thus be in the 5 different stages of the pipeline. First, the instruction fetch, then instruction decode, execution, memory, and write back. Every instruction starts in a stage and then goes to the next one. Such as after 5 instructions, there is always one instruction in every stage of the pipeline. You can see here the life cycle of an instruction in every stage of the pipeline. We will then see dependency hazards. Those dependency conflicts happen when an instruction needs the result of a previous instruction. For example, if you do 2 movie instruction and then an add instruction, the add instruction will need to use the result of the movie instruction, even though maybe the movie instruction is not out of the pipeline. For this, we will see that there is a way of mitigating it, which is data forwarding, which is handled by the processor, which is described here. And then another special case that will create what we call a bubble, when the data forwarding is impossible. You will see this during the lab. And then there are the control conflicts. When there is a jump-in instruction in any code, the processor cannot know which is the next instruction that is going to be executed. Therefore, it needs to make an assumption, and this assumption can be wrong. This will cause an accident, and some cycles may be lost in what we call a stomp event. Note that there is no assignment this week, however, I advise you to still go through all the questions. This is the simulator for the pipeline version of the processor. You can see it resembles very much the first simulator that you ever used. The main difference between the previous simulator and this simulator is the new architecture. You can see here that there is a lot more control units there. Each control unit plays a role into handling the different stages of the pipeline. You can also see that there is a lot more buses in this processor. This allows for data forwarding from almost any stage of the pipeline back to the LU to mitigate some possible data dependencies. In this simulator, you will be able to run some code in the pipeline version of the processor. For example, here I loaded example 1. You can see I can run it instruction by instruction and check every stage of the pipeline and which instruction is currently in. You can also see that there will be alerts during the execution. Those alert you if there is a data forwarding, a data hazard, a stall event, or a stomp event. In this simulator, you can also see the timing diagram, instruction by instruction, or stage by stage. In this diagram, you can see every instruction being executed and at which moment it reaches every stage of the pipeline. You can also see the value of the CPI that you will need to calculate later. I also advise you to download the PDF related to this architecture. You can find it on the UV and the simulator risc-pipe.pdf. In this file, you will find all the information related to this pipeline architecture, how all the register works, and also a description of all the control modules that you can find in the processor. Now I'll let you start with the lab. Feel free to ask questions during the Q&As.